So, electronegativity, I definitely want to talk about this one before I go because it is so important in all kinds of chemistry. Oh. It's really helpful in organic chemistry. It is helpful in inorganic chemistry. We use it all the time. It has effects on intermolecular forces, so it's really shows itself in many places. I'm going to draw our little arrow that we've been doing across a period. All right, so first off, what is electronegativity? We should talk about that first, right? Okay, so electronegativity is always in the context of a bond. So you need to always have one thing bonded to another thing. And so in our previous example with ionization energy, we were just talking about an atom by itself and removing an electron. Okay, but with electronegativity, this is the ability of an atom, I could say an element, to attract electrons. And again, in a bond. So it's always in the context of being bonded to something else. And so you see that one element bonded to a different element, they will be either sharing those electrons equally, or one will be more electronegative and it will pull electrons towards itself. So because effective nuclear charge, the electrons are getting pulled towards the nucleus, and if that trend is increasing as we go across a period, that also means that if there's a greater effective nuclear charge pulling in electrons, that means that the elements on this side of the periodic table, they're going to be really good at pulling in electrons from other elements too that they're bonded to. So that's why fluorine is the most electronegative element on the periodic table that bonds to other things. You know, of course, we have our noble gases, but they're not bonding to anything because they're very stable on their own. But fluorine, extremely high effective nuclear charge, and when it bonds to anything else, it is going to then be able to pull electron density towards itself. So electronegativity across a period increases due to increasing effective nuclear charge. Okay,